Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to use asymptotes to sketch a graph of rational functions. So in one of my previous videos here we discussed the asymptotes of the function x squared plus 1 over x minus 1. It has a vertical asymptote of at x equals 1, and it's got an oblique asymptote of y equals x plus 1, and that came from taking x squared plus 1 and dividing it by x minus 1 and looking at large values of x. So first thing I'm going to do when sketching this is put the asymptotes in. And I'm going to go ahead and put the vertical one in first. So this thing's got a vertical asymptote at x equals 1. I'm going to just put that here fairly arbitrarily. Alright, so x equals 1. Might need some down here too. Alright. And then it's got a oblique asymptote of y equals x plus 1. And that has an intercept of 0, 1. So let's see, I've already kind of set a scale, so that's 1. I want to go about the same distance up. That's going to be about right there. And it's got a slope of 1. Oops. I think that looks like it's got a slope roughly of about 1. Delta y over delta x, okay. So there is a graph of y equals x plus 1, at least approximately. Now, this point right here would be the point 1, 2. I don't know that that's going to be important for us. This is the point 1, 0. This would be the point minus 1, 0. Now I'm going to go ahead and start sketching our function. Now, I like to have just a few points to put in here. You'll notice that the numerator of this can never equal 0, so this thing never crosses the x-axis. Let's get a couple data points maybe over to the left here, maybe negative 2. So I'm going to look at f of negative 2. And that's going to be negative 2 squared plus 1 over negative 2 minus 1, which is going to be 4 plus 1, which is 5 over negative 3. So that's approximately negative 2.67, or I'm just going to approximate it about negative 2.7. That point on the graph, when x is 2, y is negative 2.7, is about, let's see, negative 2, or 2 over. Negative 3, I believe that puts us down below this line, maybe about here-ish. Because if I run a negative 2 through this, we get negative 1 out. Now, I'm going to get another point over here as, let's see where this thing crosses this axis. If you put in 0 in for x, we get 1 up top, minus 1 in the bottom. So this goes through the point 0, minus 1. And believe it or not, those 2 points combined with the asymptotes are enough to basically get a sketch of this graph. This thing has to approach the asymptote this way, and it's got to approach the vertical asymptote this way. So this graph is looking something like this. I know it doesn't cross the x-axis because this does, if I put a 0 here, this has no solution for x. So as you can see, using just 2 points, I was able to sketch in what that graph looks like. Now I realize it's kind of a rough sketch, but again, I've only used 2 points and no calculator. I'm going to take a look over to the right here now. This was x equals 1. I'm going to look for a value at about x equals 2 and just see what this thing looks like. F of 2, I'm going to get by putting 2 here. We're going to get 2 squared plus 1 over 2 minus 1. Which is 5 over 1, which is 5. Now you notice if I put 2 into my linear function, that gives me only 3 out, so that 5 is up here somewhere. I know that this thing has to approach the asymptote, the vertical asymptote coming this way. Darn it. And it's got to approach the linear asymptote going this way. So there's again, it's a really rough sketch, I realize, but there's a reasonable sketch of this function. It looks something like this, and I've only plotted 3 points. by using the asymptote, and some other knowledge like noting that it never crosses the x-axis, because if you put a 0 in for y, there's no solution for x. So taking note that it never crosses the axis, plotting 1, 2, 3 points, and knowing that it has to converge to the asymptotes. And the fact that it never crosses the x-axis is how I knew this went this way, down instead of up. You can also find that by taking limit of this expression as x approaches 1 from the left. You'll end up with minus infinity. If you take limit of this expression as x approaches 1 from the right, you'll end up with plus infinity. So, not the best graph I've ever drawn, but a reasonable first example. Hope this video helps demonstrate how to use asymptotes to draw graphs. Have a great day.